Are you looking for important questions for maths paper for your school board exam? Are you looking for a place to find such questions and its detailed explanation? Yes, this is the right place for that. Hello, I am Rajesh Bhaskar. Welcome to our channel Be More, where you can find questions and its solutions in various categories like MCQ, FIB, very short answer type, and long answer types. So, let's get started.
This video shows you more questions in MCQ and short answer categories which are more likely to come for the examination. So, we start with the MCQs. If vector A and vector B are two non-zero vectors, then vector A plus vector B dot vector A minus vector B is equal to, options are A, vector A minus vector B the whole square, B, vector A plus vector B, C, vector A plus vector B the whole square, and D, A square minus B square. So what is the answer? The answer is option D. Now we will see how it came. Now multiply each term of the first factor with each term of the second factor of A vector plus B vector dot A vector minus B vector is A vector dot A vector minus A vector dot B vector plus B vector dot A vector minus B vector dot B vector, which can be simplified as A vector square minus B vector square, which is nothing but modulus of A vector the whole square minus modulus of B vector the whole square, which is nothing but A square minus B square. If the vectors 3i plus lambda j plus k and 2i minus j plus 8k are perpendicular, then lambda is, options are A 14, B minus 14, C 1 by 7, D 7. So the answer is A. Let the given vectors can be marked as vector A and vector B. So A vector is 3i plus lambda j plus k and B vector is 2i minus j plus 8k. Since it is given that they are perpendicular, their dot product is equal to 0. So we can write A vector dot B vector is equal to 0. Why 0? Because A vector dot B vector is given by AB cos theta, and the angle between the two perpendicular vectors is 90. So cos 90 is 0, and hence its dot product is 0. So now it becomes 3i plus lambda j plus k dot 2i minus j plus 8k, which on simplification gives 6 minus lambda plus 8, and we are equating it to 0. So 6 minus lambda plus 8 is equal to 0, which becomes lambda is equal to 14. By the way, this is yet another video of the series showing solved problems of plus 1 and plus 2 mathematics paper. If you are new here, consider subscribing in order to get all the videos at the earliest. Now, mod A vector is equal to 3, mod B vector is equal to 4, then the value of lambda for which A vector plus lambda B vector perpendicular to A vector minus lambda B vector is. Options A 3 by 4, B 9 by 16, C 4 by 3, D 3 by 2. Answer is A. As said before, when two vectors are said to be perpendicular, then their dot product is 0. So in this case, we can take their dot product. So that is vector A plus lambda B vector dot vector A minus lambda B vector, and we equate to 0. Multiply each term of the first factor with each term of the second factor, we get mod A vector square minus lambda square into mod B vector square is equal to 0. Substituting the values of mod A vector and mod B vector, we can write 3 square minus 4 square lambda square is equal to 0, which can be written as 9 is equal to 16 lambda square. Therefore, lambda is equal to 3 by 4. Now we will jump into short answer type question. Find the angle theta between the vectors A vector is equal to I plus j minus k and B vector is equal to I minus j plus k. So It is given that A vector is equal to I cap plus j cap minus k cap. For any vector A represented as a1i plus a2j plus a3k, its modulus is given by square root of a1 square plus a2 square plus a3 square. Similarly, for this case, modulus of a vector is given as square root of 1 square plus 1 square plus minus 1 whole square, which is equal to root 3. Similarly, modulus of b vector is given as square root of 1 square plus minus 1 whole square plus 1 square, which is equal to root 3. Now, if you take the dot product a dot b, we can write I plus j minus k dot I minus j plus k. Multiplying each term of the first factor with each term of the second factor and simplify, we will get 1 minus 1 minus 1 is equal to minus 1. We know dot product of vector A and vector B is given as modulus of A vector into modulus of B vector into cos of angle between the A vector and B vector. So cos theta is given as vector A dot vector B divided by modulus of A vector dot modulus of B vector. Substituting, we get minus 1 divided by root 3 into root 3, which is equal to minus 1 by 3. If vector A is equal to 3a minus j minus 5k and vector B is equal to I minus 5j plus 3k, then show that vector A plus vector B and vector A minus vector B are perpendicular. So here it is given that vector A is equal to 3a minus j minus 5k and vector B is equal to I minus 5j plus 3k. Now we get vector A plus vector B as 4i minus 6j minus 2k. Similarly, we get vector A minus vector B as 2i plus 4j minus 8k. Now we are asked to find out vector A plus vector B and vector A minus vector B are perpendicular. The best way is that find their dot product, and if the dot product is 0, we can conclude they are perpendicular. So A vector plus B vector dot A minus B vector is equal to 4i minus 6j minus 2k dot 2i plus 4j minus 8k. With one simplification, get 8 minus 24 plus 16, which is equal to 0. Hence we can prove that they are perpendicular. If I plus j plus k, 2i plus 5j, 3i plus 2j minus 3k and I minus 6j minus k are the position vectors of the points A, B, C and D respectively, find AB vector and CD vector, and also find out vector AB and vector CD are collinear. Let vector A is equal to I plus j plus k, vector B is equal to 2i plus 5j, vector C is equal to 3i plus 2j minus 3k and vector D is equal to I minus 6j minus k. We are asked to find out vector AB and vector CD. So vector AB is equal to position vector of B minus position vector of A. So we are given the position vectors of vector B and position vectors of vector A. So vector AB is equal to 2i plus 5j minus I plus j plus k, which on simplification will get I plus 4j minus k. Now modulus of vector AB is equal to square root of 1 square plus 4 square plus minus 1 whole square, which is equal to 3 root 2. By similar method, we will get vector CD as minus 2i minus 8j plus 2k, and modulus of vector CD is 6 root 2. Suppose theta be the angle between vector AB and vector CD, then cos theta is vector AB into vector CD by modulus of vector AB into modulus of vector CD. Now by substituting the values and multiply each term of the first factor with each term of the second factor, we will get 1 into minus 2 plus 4 into minus 8 plus minus 1 into minus 2 by 3 root 2 into 6 root 2, which is equal to minus 36 by 36, which is equal to minus 1. So we get cos theta as -1. So theta, the angle is pi. Therefore we can say vector AB and vector CD are collinear. Two or more vectors are said to be collinear if they are parallel to the same line, irrespective of their magnitudes and directions.
So, if you really enjoyed, don't forget to subscribe to my channel. Make sure you hit the like button below and leave your comments. Also, click on the bell icon and turn on the notifications. Thanks for watching.